with the second subtopic of the chapter 5, which is the quantum numbers. Okay, what is the quantum numbers? Okay, each of the electron in an atom is described and characterized by a set of the quantum numbers. Okay, if let's say we have lithium. Okay, how many electrons that the lithium has? Please check your periodic table. Lithium is element number 3. So it has 3 electrons around the nucleus of the lithium, and each of the electron, okay, in the lithium atom and also other atoms, okay, not just for lithium, each of the electrons are described and also characterized by a set of quantum numbers, okay, that consists of set of 4. Okay, we have 4 quantum numbers. Okay, in which the first one is the principal quantum numbers. Second is the angular momentum quantum numbers. Principal is N, angular momentum is L, magnetic quantum numbers ML, and the electron spin quantum numbers MS. Remember N, class? Do you remember N? No response?
Yes.
Okay. N will make the size of the orbitals greater. Okay, do you remember L? The angular momentum quantum numbers, the value of L is the one that determines the shape, either it is S, P, D, or F.
Yes.
Okay, and then the third one is the magnetic quantum numbers, okay, which is ML. Okay, we also have found this ML when we know there are 3 orientation of the p orbital and 5 orientation of d orbital in space because of the ML value. Okay, and then finally the MS, we haven't seen this, okay, the MS value. So all electrons, okay, as what we have in the lithium, it has 3 electrons. So each electron in the atom of lithium will have its own set of quantum numbers that consists of N, L, ML, and MS. Okay, it is the same as us. Okay, each citizens of the Malaysia, okay, each of us have our IC number, right? Okay, the IC number is our characteristic. Okay, the number in the IC, okay, all the values in IC will characterize us, right? Okay, in which the first 6 numbers determine the first 6 number. For example, IC number 84115045388. Okay, if we have this number, the first 6 numbers will be our birth date, right? Okay, and then the second one, the second part will determine where we were born, right? Okay, and the last 4 is our numbers actually. Okay, so it is the same as the electrons. Okay, they have the first number, which is the principal quantum numbers. Second one is the L, momentum, angular momentum quantum numbers. The third one is the magnetic, and the last one is the MS. Okay, we look at how to identify their numbers one by one. Okay, so what is the principal quantum numbers? Okay, the value of n or principal quantum numbers will determine the energy of the orbital. The value of n determine the energy of the orbital, and we know that in the orbital it consists of the electron, so the energy of the orbitals at the same time will determine the energy of the electron in that particular orbital. The value of n also will determine the size of the orbital and also the distance of the electron, okay, and also the orbital from the nucleus. Okay, and the value of the principal quantum numbers only have integral value starting with 1. Okay, it has 1, 2, 3, 4. We don't have decimal point value, 1.5, no. Okay, we have only 1, 2, 3, 4, and so on. Okay, so look at to these orbitals. There are 4 orbitals given S, 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 S. Okay, the end of this orbital is 1. Compare with the second orbital, it has n equal to 2. See, the size of this orbital is greater than this, is larger than this. And then n3, the size of orbital bigger than this. N equal to 4, the size of this orbital bigger than the one that have n equal to 3. Okay, it is because n determine the size and also the energy. Okay, size, energy, and distance from the nucleus. Okay, because we know that we have a nucleus at the center. The bigger the size, if let's say the electron is here at the end of the orbital, of course that the distance from the nucleus and the electron is further as compared to if we have the electron here and its nucleus. Okay, so the electron is closer when the size is smaller. That is determined by the principal quantum numbers. Okay. And then the second quantum numbers is the angular momentum quantum numbers, or it is known as L. Okay, other name subsidiary azimuthal or orbital quantum number. See, the other name is the orbital quantum numbers. That is why the L will determine the shape and the type of the orbital. Okay, and the value of L are 0 until n minus 1. N is the principal quantum numbers just now. Okay, the value of L starting with 0 until n minus 1. So that if let's say your n is 5, if let's say n is 5, the L value will be 0, 1, 2, 3, 4. Okay, why is stop at 4? Because L is equal to 0 until n minus 1, in which n is 5. Okay, the value of L will never be the same as its n value. See, that is L. So that when L is equal to 0, when the value of L is 0, remember that the orbital will be spherical orbital, spherical shape or S orbital. If L is 1, it will be P orbital with the dumbbell shape. Okay, and then if L is equal to 2, it will be D orbital with 4 lobes. Okay, and for the L equal to 3, the type of the orbital will be F. Okay, we have only 4 type of orbital, which are S, P, D, and F. Okay. So since that L is depending on N, okay, so that the orbital with the principal quantum numbers of N will consist of exactly the same number of subshell. Okay, so let's look at to the example when the principal quantum numbers is equal to 1. Okay, N is equal to 1, the L value will be 1 minus 1 because L is N minus 1, right? Okay, L is equal to N minus 1 starting from 0. So 1 minus, 1 minus 1 is equal to 0. Okay, so when L is equal to 0, we know that it is S orbital. Okay, and then the name of the orbital will be 1s. Why we have 1 at the front? This 1 at the front is actually indicate the n value. Why it is S? S is come from the L that is 0. L0 is S orbital. And then when n is equal to 2, okay, the L value will be 2 minus 1. Okay, starting from 0, so that the L will be 0 and also 1. Okay, so we have 2L value when n is equal to 2. Okay, the n value is like the level. Okay, at the first level, the first shell, petala yang pertama, okay, we have only L equal to 0, means that we only have a S orbital. But in the second level, when n is equal to 2, okay, we have 2 L value, which are 0 and 1. So that the name of the orbital will be, since that the one L is 0, it will be 2s. L1, it will be 2p. p orbital. Okay. As for n is equal to 3, the L value will be 0, 1, and 2. Okay, there are 3 L value. Okay, because L is equal to 0 until n minus 1. Okay, 0, 1, 2, 3. So that the orbital for this L0 is 3s, L1 is 3p, L2 is 3d. Okay, why SPD? Why it is SP and D? Okay, they are SP and D depends on this L value. Okay, and then why they have a 3 at the front? Okay, this 3 is actually indicated or is determined by the principal quantum numbers. Okay. And then next is the magnetic quantum numbers, ML. So the value of ML will indicate the numbers of the orbital. This is the third quantum numbers, magnetic quantum numbers, or ML. The value of ML will indicate how many orbitals that we have, okay, with the particular L value. Okay, this is when we determine, when we see that if we have a L orbital, if we have a S orbital, it has only one orientation in space. If we have P orbital, it has 3 orientation in space. Okay, it is because the ML value is actually negative L to positive L. So that if let's say your L is equal to 0, the ML will be 0 only because it is negative L to positive L. But if L is equal to 1, the ML will be negative 1, 0, positive 1. If the L is equal to 2, the ML will be negative 2, negative 1, 0, plus 1, plus 2. Okay, this is how we determine the ML value. So look at to L0, ML only one figure, which is 0. So that is why we have only one orientation for S orbital. Okay, L0 is for S orbital, right? L1 for P orbital. L2 is for D orbital. Okay, so P orbital we have 3 orientation in space. Why? Because we have 3 ML value. -1, 0, and +1. So -1 is for PX, this is PY, this is PZ. Okay. And then when L is equal to 2, ML is -2, -1, 0, +1, and +2. Okay, we have 5 values. That is why D orbital have 5 orientation in space. And the last one is the electron spin quantum numbers. Okay, MS. So the value of MS determines the direction or the spinning motion of the electron. It's either the electron is clockwise or anti-clockwise. Okay, so the value of MS either plus half or negative half. Okay, only 2 values of the electron spin quantum numbers, either plus half or negative half. Okay, so this is the determination of the quantum numbers and also the orbitals that we have. Okay, let's look at 2 when n is equal to 1. Okay, when the principal quantum numbers is 1, we have only one L value because L is n minus 1. Okay, starting from 0. N1, L is 0. So the name of the orbital will be 1s. Why 1? Because of this principal quantum numbers is 1. Why it is s orbital? Because L0 for s orbital. Okay, so when L is 0, the ml value will be 0, only one value. Okay, why it is 0? Because the ml is negative L to positive L. Okay, so since that we have only one ml value, orbital that we have only one orbital in space. Okay, so 1s, we have only one orientation in space. When n is equal to 2, it is like we are at the second level of the atom. Okay, at the second level of atom, we have two L value, which are L0 and L1. When L is 0, the name of the orbital become 2s. When L is 1, the name of the orbital is 2p. Okay, 2 and 2 because they are at n equal to 2. 2s orbital. Okay, look at to the ml value. We have only one ml value. The ml value is actually referring to its own L. Okay, we have this negative 1, 0, and 1 because of its L that is 1. Okay, so when L0, ml only 0, so that the number of the orbital in 2s is 1. We have only one orientation in space. As for the 2p orbital, since the L is 1, ml will have 3 values, so that we will have 3 orbitals or 3 orientation in space. Okay, so that altogether at the second n, okay, at the principal quantum numbers 2, we have 4. Okay, 1 plus 3 orbital, we have 4 orbitals at the second level at n equal to 2, at the principal quantum numbers of 2. Okay, if the principal quantum numbers is 3, so that the L value will be 0, 1, and 2. Okay, the ml value is corresponding to its L. Okay, so this ml is responding to this L, since that it is 0, the ml only 0. As for this ml corresponding to this, since that L is 1, the ml will be negative 1, 0, and plus 1. And this ml value, negative 2 until positive 2, is actually corresponding to this L value that is 2. Since that we have one value here, we have one orbital for 3s. Okay, since that we have 3 ml value, we will have 3 orbitals of 3p. Since that we have 5 ml value, we will have 5 orientation or 5 orbitals of 3d. Okay, that is the relationship between n, principal quantum numbers, L, and also ml. Example problem 7.8, we have to identify the incorrect quantum numbers. When n equal to 1, when n is equal to 1, L can be 1?
No.
Adam, when n equal to 1, L can be 1?
No, sebab L sama dengan N tolak 1.
Yes, because L is 0 until n minus 1. Okay, since that our n is 1, L will be n minus 1. So n is 1 minus 1 equal to 0. So the only L value for n equal to 1 is 0. Adam, ML can be 0.
Yes.
Yes, why?
Um, sebab apa? Sebab ML dia bergantung pada L daripada negatif L ke positif L.
Yes, because ML is negative L to positive L. So when you said that your L is equal to 0, so that the ML will be 0. Adam, what is the name of the orbital when N1, L0, ML0? Is it 1p? Is this correct?
No. it should be 1s.
Yes, it should be 1s orbital. Why s, Adam? Why not p?
Um, sebab s orbital sebab L equals to 0 and it is
Yes,
staggered.
because L is equal to 0. When L equal to 0, the orbital will be s orbital. Okay, and then B. Putri Arina.
Yes, madam.
Okay. When n equal to 4, L can be 3.
Yes.
Yes. When L is 3, ML can be plus 1.
Yes.
Okay. What are other possible ML value?
-3, -2, -1, 0, +1, +2, +3.
Okay, there are 7 values of ML. So is the name of the orbital is 4D?
No, it should be 4F because
Yes, it
the
should
L
be
is
for
3.
F. Yes, because L is 3 for F orbital. Thank you. Then the third one, Abdul Azim.
Yes, madam.
Azim, when n equal to 3, L can be 1. L is equal to 0 until n minus 1. Not just n minus 1.
Oh, okay. L.
L is equal to 0 until n minus 1. So L can be 1?
Yes, madam.
Yes. Okay, what are other L value when n is equal to 3?
0 and 2 and 3.
N2 and 3?
0, 1.
They can n minus 1. Yes, 0, 1 and 2. And then the ML value. When the L is equal to 1, ML can be -2.
No, madam.
Okay, why?
Because ML is equal to -L and to positive L. So which mean L
So your ML either?
either negative. Ya, ML sepatutnya -1, 0 and +1.
Yes, correct. Okay, now this is wrong, right? Okay, it's either -1, 0 and +1. Is the name of the orbital is 3p?
Betul.
Yes, it is 3p. Why it is 3p?
3P sebab 3 tu N, base N.
Yes.
P sebab L equals to 1.
Yes, correct. Thank you.